How's it going, guys? Welcome back to Stats for this week. We just have a quick little video with a couple problems at the end of it for you today. And then we will see you tomorrow. So today we're talking about calculating correlation. We saw how to do it in the calculator before, but this is the formula for it. And the way it works is we have like our two lists. We'll call it I guess L1 and L2 to match our calculator. And we think of list 1 as being all the x's, x1, x2, x3, all the way down to xn. Same thing with L2, y1, y2, y3, all the way down to yn. And we can make a scatter plot of this using our calculator. And we can calculate correlation using our calculator. But here's how you would do it by hand. If I was to average all of these, all the x's, I'm going to get x bar. I'm going to average all the y's, I'm going to get y bar. And I also calculate standard deviations, sx and sy. And if I want to calculate correlation, what I do is, since n is the total number of pairs, I do 1 over n minus 1. And again, that has something to do with sample versus population. And then how do I calculate this? Well, I take, at each step, I'm going to take our x value, I'm going to subtract the mean, I'm going to divide by the x standard deviation, which I have right here. So I take x1 minus the x mean divided by the x standard deviation. And then I'm going to do y1 minus the y mean divided by the y standard deviation. Now these have to be x1 and y1, and I'm going to multiply them together. Then I'll do it with x2, the x mean and the x standard deviation, and y2 with the y mean and the y standard deviation. Multiply those together, and then add it to my previous step, and so on and so forth, which gives us the formula for correlation. We see it is a little bit of a mess to calculate. Compactly using kind of our sigma notation, I can write this as 1 over n minus 1, the sum of xi minus x bar over sx minus yi over minus y bar over sy, and you should be able to see that these two things are indeed the same. All right, so I want to talk here about part A, and then part B and C I want you to do as a problem. Explain why this is improper to say, and really the reason is because correlation has no units. Like, correlation is just a number that tells you how well associated two different bits of data are. It has no units, so there is no unit on our correlation. And now if you could try B and C on your own as part of the problems here. So perhaps you can pause the video and try that before we move on. Excuse me. All right, so now we have a regression line. And this is actually really related to correlation. Correlation, right? So correlation is a measure of how linearly related two data sets are, right? Like positive, negative, we did all that stuff last time. So the regression line is a line which will kind of show the relation between two data points, and has a little weird form in statistics. Instead of y equals mx plus b, like we normally see, in stats we use this formula, right? And it's just the same, right? It's a number times x plus a number, or in this case, a number plus a number times x. But this little guy at the beginning is called y hat. Y hat. That little caret guy is considered a hat. So this is y hat equals a plus bx. And then I give you some information here. This is what you already know about a line. All right, so, excuse me. Big question is, why do I use this instead of the normal line variables? Well, there's two reasons. On the formula sheet you get on the AP exam, this is the version it's given to you, and also in the calculator, when you calculate a regression line, it's in the a plus bx form. Okay, so let's see an example. For this data here, which is how many miles a car has been driven based on its price, we can make a scatter plot for this data, and then what a regression line will hope to do is to fit itself in a way through the data which is reasonable to describe the data, right? So, and this one seems fairly reasonable, right? Our data has a negative correlation. And this line is a line with negative slope that kind of goes through all of the, goes through the middle of the data. It goes through the middle of the data. And of course, we're going to analyze how good or bad one of these regression lines are. But that's for a different time. All right, and here's the calculator steps for how to do a regression line. And what I would urge you to do is to go through these steps for this data set and make sure you get the same pictures. Make sure you get the same information. All right, after we work on this problem set and do this video, I'm going to assume that you know how to do linear regression on the calculator. So I would suggest practicing right now. All right, but there's one more way to do regression. And that's if you know some information about your data. So if you know the mean of the x values and the mean of the y values, if you know the standard deviation of the x values and the standard deviation of the y values, and you know the correlation coefficient or the correlation number r, you can calculate b in our formula, as it is right here. And you can also calculate a using this formula. Now b is just the slope. This is the slope, and this is the formula for the slope, so this is something to memorize. But we note that our regression line, which is our least squares regression, which we're going to discuss in class, our regression line always goes to the point x bar comma y bar. So if I want to know the y-intercept, of a line, and I know it goes through this point, I can actually calculate that y-intercept by doing a equals y bar minus bx bar. Okay? Now, what do I want you to do for problems? I want you to do problems 3, 4, 6, and then that's it in that section. Over here, I want you to do all of 51, all of 52, and then all of 70. Okay, should be some good practice for you. That's it for today, gentlemen. Have a great day.